Hello, my name is Taylor Brown. I'm a lead program manager on the Windows container team. My team is responsible for all of the server container technologies that we're bringing into Windows Server 2016. We're incredibly excited to be bringing this technology to Windows users now. When we think about containers, we often think about developers. And it's true, containers are a very developer-centric technology, but they still have a great use case in IT pro and operations environments. Today, we're going to talk about one example of how you can use containers in your existing environments. Now to get us started, I'm going to open up an instance of Internet Explorer and navigate to a website. So this is just a basic ASP.NET 4.5 application. It's the sample application for Visual Studio that's running on a server somewhere in my environment. It happens to be a virtual machine on this laptop, but it could be anything on any different server running .NET 4.5. Now if we take a closer look at the site, we go to the root, we'll find out that it's running on a server running IIS 8.0, which is what Windows Server 2012 shipped with. Now, if we connect to our Windows Server 2012 machine and take a look at Task Manager, we can see that this machine is using 3.4 gigs of memory out of a 4 gig allocation simply to host this one website. That's an awful lot of memory to be using for a simple basic .NET website, but often this is the case over time. We see that these servers continue to use more and more resources just to serve very basic application needs. If we look in IIS, we can see that, in fact, we have a default website with just my site installed on it. So let's see how we can move this into containers and what some of the benefits of that are going to be for us. So we'll start by just exporting our application, going through our export wizard, and we'll make a package on our desktop called mysite.zip. There we go, we're exporting that. And we've now completely exported the website. So if we look at our desktop here, we've got mysite.zip with a set of files inside of it. So we'll go ahead and copy that for use in just a moment. We're now done with our Server 2012 machine. We'll connect to a Server 2016 machine that's going to act as our container host. Now, just like we did before, let's go ahead and take a look at the configuration of this machine first. So it's using 1.6 of the 4 gig allocation assigned to it, with nothing running on it right now. So let's go ahead and start our first container and just see how that works. We're going to use a tool set called Docker. Docker is a container management tool set that works on both Linux and Windows. It's an open source project that Microsoft has been contributing to heavily over the last year and a half. So we interact with this through a command line tool called Docker, or through PowerShell, but I'll get to that in a moment. So the first thing we're going to do is just start a new container. We'll say Docker run -it, specifying that I want an interactive console for this container, the name of the container image, so Windows Server Core, and then the command I want to run inside. Now, before I execute this and start this container, one thing I want you to keep an eye on is the memory usage on this server as we start this. Currently, we're using 1.6 gig of our 4 gig. Now, when we start this container up, we can see that our memory usage went up to about 1.8 gig. So we used about 200 meg of memory to start this container. And did you notice how fast the container started up? In under 2 seconds, we've got a new container or instance running on this machine. Now we can look around this container and see that it's got a file system, it's got an IP address. We can even do things like task list and list all the processes that are running. Now, one thing that's interesting to compare is the number of processes shown here compared to what the host sees. So we can see on this host, we see many, many more processes. In fact, we see some of the same processes in both places. So for example, 2544, which is SMSS, we can see on this host, SMSS running as 2544 as well. That's because as a Windows Server container, we're sharing the kernel amongst the container and the host. And so the host sees everything while the container has been virtualized and only sees the processes that were started inside of it. So now we started our first container, but we don't have an instance of IIS running and we don't have our website running. Let's go ahead and start figuring out how that will work. So I'll exit this container. We can see our memory usage will start to drop as soon as the memory is reclaimed. So we can see the dip that happened there. And now we're going to go ahead and create our website container. Now, how do we go about doing that? Well, the first thing we need is we need IIS Then we need the web deploy toolkit installed, which is what we use to import the package that we created on the server 2012 machine. So I've already downloaded an IIS container image from the Docker Hub. And if I do Docker images as a command, I can see that IIS image has been pulled down. Now I need to install the web deploy toolkit. How would I go about doing that? Well, we can use a tool called a Docker file. So I'm in this Docker files directory. And if I open this up, there's a web deploy folder here. If I open that web deploy folder, I've already gone ahead and downloaded the web deploy toolkit from Microsoft. And then there's a file called a Docker file. If we open this up, what a Docker file is a set of instructions for building a container image. You could kind of think of it as a bash file or a PowerShell file for a script for creating containers. So it's got a set of instructions. It says start from IIS, the image we already downloaded, and then it's going to add or copy the MSI from its local directory into the root of the containers directory. And then we're simply going to run MSI exec -I for interactive or for install, the name of the MSI, and -qn for a quiet, non-intrusive install. So we'll close that. We'll go back over to our command prompt and we'll say docker build -t for the name of the image we want. We'll call that web deploy, and then the directory to the Docker file. I could either use relative or fully qualified, completely up to you. So we've now told Docker to go off and start building that. And we can see that it's running from IIS. We can see it's running MSI exec inside of the container. If we look at our task manager right now, again, since we're running as a Windows Server container, we see our MSI exec instance. One thing that I'll call out is we can see that it's associated with this job object. That's one of the ways that we've built containers, is using this notion of job objects. So everything running with job object 322 was running in that container. They've all gone away because MSI exec is done, and our container is now ready to go. Or I should say our container image. So if we look at Docker images now, we've got our web deploy image. So now we've got our web deploy. Now we're ready to create our container image for the website. So we've got another directory here, my site import, and there's the my site zip file that we created a few minutes ago, and another Docker file. Opening up this Docker file, we'll see that it starts from the web deploy image we just built. It adds in mysite.zip to the root of the directory. Then it uses PowerShell and runs the add ps snapin command to install the web deploy snapin, then restores the package from our server 2012 machine. Now this next line is kind of interesting. Command is the keyword for saying what command to run when this image is started. And in this case, we're saying start with PowerShell, -command, and then the command we want it to run is while true, curl 127001/mysite every 20 seconds. What this means is that if for any reason inside of the container it can't access its own loopback interface with mysite on it, the container will exit immediately. We can get an event from that, and we can even have the container automatically restart. So we're even actually giving ourselves some extra level of testing while this container is running all the time. So let's go ahead and build this container now. So again, we just simply say docker build -t for the name we want it to use, mysite import, and then we'll use a relative path this time, mysite import. So now we're off building our container image. And so we can see it's running PowerShell. It's building that container image. It's now imported the site, and our container image is ready to go. So we can say Docker images, and again, we can see we've got our mysite import image. So now we're ready. We're ready to start a new instance of our website. So how do we do that? Again, we're just going to say docker run. This time we're going to say -d because we don't need an interactive console. This is ready to go. We can just run it as a service or a background container. We're going to say what port we want it to listen on. So we're going to say from port 80 on this host to port 80 in the container. So that's what port the website's configured on. And the name of our image. So mysite import. All right, we are ready to start our first instance of this website. So there we go, we've kicked it off. And now if I go back over to our web server here, and I go to the IP of this host, we see our IIS instance, and if we go to My Site, we've got our ASP.NET application up and running. Well, that's fun, but what happens if we want to run up a second one? So we'll say 81. Well, as simple as that, we've got a second instance of our website up and running. Now I can also go look at our task manager here and look at our performance. So now we're using 2.2 gig of memory, well, 2.1 gig, but we're running two instances of the website simultaneously. So again, we've got 80 and 81 running at the same time. But remember how I talked about how we're using a shared kernel, and so all of the same processes are present. So there's the 392, there's the 412. Well, for some environments, that may not be enough isolation. Regulated industries, things like PCI and HIPAA compliance, may dictate that you need a stronger level of isolation, an isolation like a virtual machine. Well, we've got an answer for you. If I simply add one additional command, so we'll start on a new port and we'll say dash isolation equals Hyper-V, same image, same machine, we're now launching this instance of the container inside of a specially optimized virtual machine. And we can see VMWP starts spinning up here. This is the virtual machine worker process. Our container is now up and running. And if I go to port 82, we've got our container website running inside of a container, inside of a virtual machine, inside of another virtual machine, all using Windows containers and Hyper-V. Now the value of this is that this is fully isolated. We don't see another instance of our website. So if I go look through our process list here and I find W3 WP, we see the two instances from the Windows Server container. The instance from the Hyper-V container is fully isolated away. It's running inside of our worker process. So we've now got 82, we've got 81, and we've got 80 all running on the same machine at the same time. Pretty neat. Now I did say we've got PowerShell, and so of course we can do a git container, we can do a git container dash stop container, and all of our containers have been stopped, including the one that was already stopped before. This is just a very brief tour of some of the technologies that we're bringing to bear with Windows containers. I'm sure that you'll find many use cases for containers in your environment, as well as helping your developers use containers to be more efficient in both their testing and development, as well as hosting their websites, their applications in your environment.